Actually, since it's the two of us, do you want to speak about the feasibility rules?
Yes. Yeah, it might be good if I got that fully into my brain. I don't know why every time we talk about it, it seems to drift away. I mean, when I think of the feasibility, it just means that it's, that it can be, it's phrased in a way that it can be contradicted.
The idea of dung is simply to record a position to any statement. So you have a statement, you have a position, and the opposition itself can be opposed, can be opposed, can be opposed. So at any point, the only unopposed statements are statements which don't have a first level opposition, which isn't itself opposed. So there's a kind of recursive rule. As we were discussing, I think it's interesting to have a support separate from the oppose. Like saying this is opposed and supported is more interesting than saying, oh, it's opposed, that's it. Well, what we also, if we also have reasons to believe this. And
yeah,
in that sense, playing with support oppose. And the other thing is the distinction we keep making, which I think is important, between the claim and its relevance, right? I could oppose the claim or I could oppose its relevance, and it should not have the same impact.
Yeah, in reason score and Gollybot, there's a setting for whether you're opposing the terminology I'm using is confidence or relevance, but yeah.
Like,
and that changes how the scores happen, although kind of in an arbitrary way.
So it might actually be useful to look into reasonable scores. I'm curious, what's your score? My score would be take the max of the support and the max of the oppose.
So I think that there's going to be multiple formulas.
Okay.
So if you're saying, trying to think of an example where, I mean, the max, I'm trying to think. Okay, so if you had a whole bunch of scientific papers and you're trying to say that they give this claim, I guess there's two ways to look at it. One, you could say, well, let's do it a different way. Let's say a measurement of a star out in space, right? So you have all these measurements and they're kind of fuzzy and they're not quite sure. So those are there. But if you get one good measurement, then that could be considered sufficient evidence to prove it. So that would be the one where you take the max.
Right.
The base formula that I went with, that I hard coded into the system right now, is more of an averaging, because it's the assumption is that you're saying we should do something, which is kind of the reason score thing, and then you're saying here are reasons for and here are reasons against, and then so you can have reasons for and reasons against, and then you can weight those by attacking the relevance. So you say, well, that one's less important, or that one's more important than all the others, and then it's a weighted average. And if it's less true, the way it goes right now is that as it gets less and less true, its weight dynamically goes down. So that's the default one, but I know there's going to be situations where there's going to be a different formula, and so I haven't built that into the system yet. But the thought of doing the max or the min, where you need something to where just one evidence against it, like you say all people are mortal, and then you find one immortal person, then that defeats it, right? So that would be the min. Yeah, the min score wins.
Yeah, I'm tempted to have the for and against independently.
What do you mean
Because
by independently?
meaning
Oh, so like a
here,
score, this is the score of all the for, and this is the score of all the against.
yeah. And so that if there's high for, high against, we know that we have a controversial statement.
Yeah, so in the way I have it today, that all that data is available.
Right.
What
And-
is, and then like we talked about before, you know, when you first saw it, it's like, oh, it's one number. Well, that, I don't know whether that means weight. I don't know whether that means importance. I don't know if that means truthfulness. And I'm like, well, we have to display one number, but I have all of that broken down so that that more advanced interface needs to, and a way to,
Right.
like, when you open it up, they want to see, well, why is the score so low? Is it because it's not true or because it's not relevant?
And basically on all the for, I take the max, and all the against, I'll take the max. And the
Oh,
probably for the incoming, and I'm less sure about that, like if, let's say I have a for and it itself is controversial. So I'd probably go for its positive score minus its negative score, clamp at 0, multiply by the relevant score, and that's its for score. Right?
are you in this? What's the final score used for? Is that, are you trying to score its controversialness?
Up to a point. Basically, something controversial has low value as a for or as an against. So I'm just subtracting
Right.
for minus against and clamping at 0, of course.
Right.
I don't want a negative for. I don't want a bad reason to lower the score of something necessarily. But Max, on the other hand, I think Max follows a certain intuition, which is correct, in the sense that the best argument wins, right?
I mean, assuming that all the child arguments are making the same point or arguing the same point.
They're not necessarily. They're all reasons. There's many reasons to believe the target, and they may be arguing in totally different ways. But the strongest one is the one to consider. Now, the question is, when do you want to say, oh, I have many weak arguments, it should be stronger than just the max because I have many weak ones. And there we get more into kind of Bayesian probability logic. Can this be false given that all of this is true, right?
Well, I guess the thing is though, is that let's say we have 5 reasons that are different, that are all equal importance and weight, and then
Let's say they're all
reason,
0.2. We've got 5.2 reasons, yeah.
Yeah, and then one reason against.
Yeah.
But you're saying that since you're taking the max of both, they would cancel each other out.
No, I'm saying, let's say the 5 reasons are 0.2, right? So I would take the max would be 0.2, and the reason against, let's say it's 0.8. So I would have 0.8 against 0.2, and so 0.8 wins against 0.2. So I have more reasons to disbelieve than reasons to believe. But what I would like is if I have 4 independent 0.2 reasons, maybe I'd like the score to be a bit higher. Maybe, well, I don't know, 0.4. It's not just adding them up, because think Bayesian rule again. Think of each of them is saying it's unlikely to, we have 5 independent reasons why it's unlikely that the target is false, really.
Yeah, if we have, well.
So it would be 0.8 squared, 1 minus 0.8 squared, something like that should be the result. But that's supposing we have a cover. I don't have a good intuition there. I know it should be higher than 0.2. I know it should be less than the sum. Because they're all weak.
Well, so in my case, it is
You do an
Yeah, so
average, right?
it's all a weighted average for mine. So it's a completely different way of looking at it. It's looking at it that I have this strong of a reason to believe it's there. I have a separate independent measure that is this strong. And so if they're both a full one, then it's one. But if I have, so if, because a lot of times you can say, well, I have this evidence that I have a study that shows that people do X, right? Well, that study can have reasons in it where it found some falseness to that, right? Like 80% of people do this. Well, so some of those facts are actually part of that claim, that part of it is pulling towards the other direction. It's
In some
not
cases.
just neutral.
Yeah, I
And
hear
I
you.
guess I'm assuming that case
Which is
in
not
mind,
always the
and
case.
that's
Yeah.
why it's weighted. That's why it's a weighted average, because so
And it
a whole
makes
bunch.
sense when it's a dichotomy, which may or may not be true. But you're right. When it's a dichotomy, it's perfectly appropriate to do a weighted average.
And that's why I'm thinking, and I guess that's most of the scenarios that I'm using it for. As a society, we should, well, like this voting rights bill, there are reasons to think we should do it, and then there are some reasons to think that, giving felons the right to vote in the United States, ex-felons, that has some negative, could have some negative consequences. But I guess you could also separate those, and then taking the max would be. So that's why I think there'll end up being several different formulas.
Well, I'm hoping there's a unifying formula which will take into account whether the thing is dichotomous or not, right? That's why I'm interested in.
Well, I mean, you can combine them all up into a formula that says if this, then do this, else this, right? But yeah, there will be different kind of mathematical, different min, max, summing, weighted.
No, that is perfectly appropriate. What I'm saying is we'd like to have an idea about where we're going, like a heuristic for applying those formulas. It's not just, oh, there's many formula, pick the one you want, and no.
Yeah, right. Yeah. And that's kind of where I get to kind of experimentation. That's why I took the one that seemed to be kind of the most common and the most intuitive. Not when you look at the math, but it's intuitive when you think, oh, how would this affect it? I found that, okay, I have this fact and I put it in there. If I use this formula, then it kind of does what I expect the numbers to move around, in most cases. But as I want to experiment with this formula, and then as I find things that break it, then we would expand it, and then we would look at ways to how do you distinguish between the two. And so it's kind of a mixture between having
I'm beginning to think this is another use case story mapping, right? What are our intuitions about how the formula should behave? Like I gave the example, if I have 5.2 reasons, I expect the total to be less than 1 and more than 0.2. But if I have 5.2 and 1.8, I expect the 0.8 to dominate. Right? But what will often happen, I suspect, is that reasons for and against will may or may not be independent, right? Often, like this 0.8 also has a reason to undermine this or that reason for, and vice versa. It's saying, well, and it's a different phenomenon, right? Are you saying this is true independently, or by the way, this reason why you believe it's false doesn't hold because X, Y, Z. And maybe these need to be teased out, and I suspect it's probably useful to do so. But often they'll play both roles. Often a study will say, oh, by the way, this undermines that study and vice versa.
Yeah, there was something else that I thought you triggered, but now I can't. I lost it. I was listening to what you said.
It's cool. So is there, maybe what we should do is, you said you had certain assumptions. Did you write them as test cases?
I mean, yeah, I mean, I have like 10 test cases that are like, 2 pros and 1 con, and I expect it to be a point something. So I do have that. It's not really written out real well, but it
I'm
works in
thinking we
code.
should try many equations and see how well they follow our different test cases.
Yeah, and actually, in having a bank of test data with like this many pros and this many cons and whether they're attacking the thing, and then we could run it through multiple formulas and see how the numbers differ and see whether that fits our intuition.
Except of course I'm doing it as a different process, right? Because I'm keeping truth and falsehood support and oppose separately. So the data is different.
I would say that each formula could or could not do that.
No.
Right. So we just need the inputs, right? I have 4 pros and 1 con, and then your formula would separate them and result. Yes, it'd result in 2 numbers for the one. But I imagine for each of them, we'll probably have multiple outputs. And reason score might have the kind of the roll up. The other thought about what you were saying is that sometimes the points are the same and not, or are covering the same point, and
they're not fully independent.
Yeah, they're not fully independent. I've been thinking about that, and this comes down to our debates on the structure of the system.
Yes.
Is that if you find that these two are dependent on each other, then should those have a parent claim underneath, right, and be grouped by other claims, rather than trying to have a bunch of children claims and then grouping them kind of in some other arbitrary way. Although grouping them in some arbitrary way could be useful, because you could say these 3 have a partial relationship, and those still have a partial, one of those still has a partial relationship with the other one, right? That you can't do if you break it down into child claims.
I guess on the other hand, it's theoretically possible that the common abstraction is not as strong a claim as the concrete subcases. Theoretically, I don't have an example in hand, but so sometimes, and yet they're not independent. That's really an interesting. How do we want to model the independence separately, or do we want to model it by introducing abstraction? I think introducing abstraction should work in most cases. And
so I mean, I've found, and this could be separate to it, but I think that when people are kind of reading through my data, it helps them to see the claim and then open up to see its children, rather than seeing a mixture of semi-unrelated children in a big list. And that's why I didn't choose to add that additional abstraction than just parent and child.
I just thought of an interesting counterexample. I was looking for examples. It's dilemmas, right? If I say, well, either this or that, and if this, then here's why it's an argument for, and if that, then here's why it's also an argument for. So the common abstraction is the dilemma, which proves nothing, but either case, either horn of the dilemma acts as a proof.
A dilemma saying something, because I use that phrase differently, but something that is based on an external piece of data that's currently unknown.
There's a dilemma means there's 2 horns, there's 2 options, either A or B. Okay, we want to prove C, and it turns out that either A or B is true, and A proves C and B proves C in a totally different way. So the common abstraction is A or B, and A or B in itself you cannot quite derive a proof for C because the proof paths for A and B are totally different. But A proves C, B proves C, and either A or B is true. That's a dilemma. That's a dilemma structure. So here they're not independent. They're actually very unindependent, but there's no common abstraction that's useful.
Yeah, I mean, so there's if you had it to where you could take a claim that took the max, then that's kind of an either, as opposed to mine of averaging.
Oh, here, that's interesting because
if you want to group by claims, then you just choose a different formula for that grouping, that for the parent grouping.
I want to say here, and that's really interesting because I don't know if A or B. So let's say I arbitrarily say that A and B are each 50-50% likely, suppose. So if A proves C, it only proves it with a 50% chance. If B proves C, it only proves it with a 50% chance. But A or B is certain, and A or B through two paths proves C. So I want a 1, but I only get a 0.5 with a max. So this is one reason not to have a max, I guess.
Or yeah, or to have an alternate.
Or to have,
multiple formulas and then some rubric on how to decide and be able to argue that's the wrong formula for this group of claims, right?
Yes.
Everything's debatable.
Everything's debatable.
Yeah, and one of the things I think about making everything debatable is just have a history built into the system, and with each message-based system, if each kind of action that's taken, you can then debate that action and potentially roll it back or reverse it.
I'm really, and this is something that bothers me to no end. I'm between, I want this deeply. I want everything to be debatable. I want everything to be open to debate. And I don't want this to become a way to sabotage the system. I don't want this to become an attack vector. And it's easy to make it into an attack vector. And I really don't have a good answer there. It's
so my opinion on the attack vectors is that it's kind of an arms race is kind of the way I feel it. And I kind of feel like we need to design kind of the core system with regardless of how things can be attacked, and then have a separate thing to where we talk about how to attack. Because a lot of times, first of all, other people are figuring out how to reduce attacks in other areas, and we want to use that. And then I also don't want our design compromised because we couldn't figure out a protection against an attack, when later on a protection can be devised that's unrelated to the structure, right? So I kind of want to not so much worry about that. While we're working on the structure, let's work with trusted individuals, and then we apply the other ones. I can't think of an attack vector that isn't mitigated outside of the design.
Okay, I really have the perspective that it's security like UX. It's you shoot yourself in the foot if you don't think about it at the beginning, or internationalization, or there's all these things that it's really hard to add as an afterthought.
Well, when you're designing the data structures or when you're writing the code? Because those are two different things.
Yeah, even at the data structure level. I mean, there's a lot, like look at the explosion of blockchain. And I think there's many things wrong in blockchain, but it is exploding because they're thinking about certain security characteristics first. And that's hugely appealing to a lot of people. and especially in this environment, security is not an afterthought. And especially when we're speaking about public debates with weaponized disinformation, I don't think security can be an afterthought.
I know that there are situations where you have to build in security from the beginning, but I mean, Twitter's been adding a lot of security and fighting stuff like that. I don't think any of that has changed their basic data structure. If you talk about someone making a tweet, you know, you put it through an AI or an algorithm to determine whether it's, you know, whether they're sending in too many tweets, but that doesn't change that tweet has 500 characters and then it has, you know,
Yeah, I hear you.
train of stuff. So I don't see how we could paint ourselves in a corner. I mean, I know it, yeah, in blockchain, but blockchain's core issue is security. It's all about proving that someone did something.
Yeah.
And I
no,
think
it's a scale, but what I'm saying is a lot of things are being built on it because it ends up being not optional. The promise of blockchain is something everybody's been wanting and nobody else has done as well. And again, I have tons of issues with blockchain, but I'm saying these I was speaking with deficient people and they said, you know, a lot of what we're promising, which is, you know, distributed identity and distributed data and complex access and access retraction and blah, blah, blah. It's complex, but for many of our users, it's the ground level. It's the minimum before they're willing to play. And it enables things once you give that as a ground level. A lot of people are like, look at the explosion in DAO technology. Is anything new conceptually in DAO? No, not at all. But DAOs were floundering on trust issues until blockchain. I'm not saying, and again, I don't think blockchain is the right solution, but it enables certain things. I hate to defend blockchain, but the point I'm trying to make is right now, public debate infrastructure that does not have a way to control adversarial disinformation is not going to fly beyond the point. It's part of the game. Now, I'm not sure what's...
And the way Jamie and I are kind of handling that is just throwing people at it.
Yep. And that's not my solution, so I have to find something else.
Yeah, and it's not a long-term solution.
Nope, it's not.
But it's a way to experiment with some other aspects of the problem.
Absolutely true.
But yeah, we do definitely need to solve it at some point.
Okay, let's get back to the score principle, because I'm really curious to be a bit more concrete about this. No, seriously,
cool.
we talk a lot, and we have a one-on-one. Let's do it, right? This step one, no, the other one, please. Thank you. And now let's VS Code. Let me open a new one. We're Zoom now. Someone Zoom. Someone see you. Should I do this in a? I could do it in a. Okay. So you should see my empty thing here.
Yep.
Okay. So let's say A, B, C statements. AT, BT, CT, the believability. AF, BF, CF, the unbelievability. Simplified model XF equals 0. We just have believability, right?
And AT, what's the lowercase t stand for?
T, true and false.
Okay. Oh, yeah. Your T's and F's look really close. I wasn't paying attention.
How's this?
That's good.
And we have A supports AB or A plus B support A attacks. That's a notation as any other.
Okay.
With relevance score. Okay, so.
Are you saying an X you put in how much it's also attacking the relevance, or are you just saying if you use an A plus X if it's relevance, or?
Yeah, let me take that out. Actually, what I'd like to.
It's either attacking the truth or the relevance, right?
Yeah. S of A, the supporting statements. Let me call it O. S A B the does that sound right?
I guess I'm not reading it well. The relevance of A is support of B. Oh, so supporting and attacking. Okay, so.
Okay, so what I was thinking as an equation was AF equals sum over, now let's start with T of
do you ever want to calculate what's the total believability? Because you have the believability of the truthfulness.
Yeah, absolutely. A X T minus XF. So the max of 0 or XT minus XF. Times S X A for X in SA. And some no, the max. That sounds right. So that's what I'm proposing. And what you're doing, you don't have false, you have, if I'm not wrong, AT equals average of xt times SXA for XA. SA minus average. No. Union. So, oops, what did I? What did I do? I didn't close, I'm pretty sure. Scoring here. Okay. And let me get zoom back. Thank you. Union. So that's a set. Minus YT times O Y for Y in O of A. Does this look like your formula?
I'm a little slow at reading that notation style.
Yeah, sorry, I'm
It
just pulled it
feels
out of my.
correct, though. The only thing is I'm not sure, is it take into account that as the score goes lower, its weight goes lower?
As the score, I'm multiplying here by the relevant score here. That's the relevant score. So that's
well, so its truth score becomes its relevance score. If it's less true, it
oh, I
less
see,
relevant.
I see what you're doing. Okay.
And then there's
so,
a separate relevance score based on
sum over sum so it's a weighted average.
yeah.
Sounds better?
Yeah.
Okay, good. Oops. I would like a Bayesian formula, but this is not it.
Right. Well, when we talk about Bayesian, I always think of Bayes saying always having a prior, but is that not the main bit of it? The main bit is how you combine the different your different facts.
The idea is the basic Bayesian formula, right? Is P of A given B equals P of B given A. What is it again? How do I not remember this by heart? Yeah. Okay, I'll look it up.
I'd be surprised if you did. I mean, I have an intuition about it. I mean, as you're getting more and more evidence, it slowly increases, and not the same as adding. Or,
yeah, that's conditional. P of B given A.
They have
P of A over P of B.
Yeah. That's what Wikipedia has.
What?
That's what Wikipedia has. Uh,
tuk, 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 yes, 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 yes. Which is pretty obvious, right? Let me do it in that form. It'll be. No, let's save. Yes, yes, yes. So if you have yeah, is that useful? If I have multiple factors, so P of A given B, C, D, E is equal to P of just curious example, defective, Bayesian, frequentist. Aha. Extended form. Yes, that's what I wanted. Oh, that's for a partition.
in that formula, is the order of A and B important, or is it?
Oh, absolutely. In the sense that this is about relating the P of A given B to the P of B given A. So those orders are important. Inside,
Yeah, so,
otherwise, no.
So if we're using this in some sort of scoring things, the order that we put them through takes precedence or has an effect. I guess it's one of the things that I wasn't sure.
No, oh, not that way, no.
Okay. If I switch the A and B values, the actual numbers, then it'll come out the same.
They would.
Okay.
Yeah. And if you look at this again, put it in this form, it's pretty obvious what's going on, right? And
What's the A and then the hat B?
A hat B, that's the end. Sorry, I should have a proper end. I was being lazy. I could use this. I was being lazy, and that the real thing to do is oh, come on. Frequently, this one is what I want. Yes, thank you.
Yeah, so I'm not familiar with that.
That's end. That's end.
Just and. Okay.
I should use the same here. And so you see, this is the definition of P of A given B, right? This is how, what is P of A, what is the probability of A given that B happened? Well, it's the probability of both happening divided by the probability of B happening. And from there, you get the other form, and then you do it symmetrically, and then you get this equality, and then you divide by P of B, and you get base formula. It's pretty trivial.
Yeah.
What is interesting is if you have a bunch of reasons to believe, can they be thought of as subcases? Now, if there's a partition of the sample space, it's very easy to extend, right? If you look at the Wikipedia let me actually make it. This is the extended form for AI partition. But that partition is not the case we're interested in. We're interested in independent factors.
Mhm.
There must be a nice way to.
Or does Bayes assume that none of them are independent?
Subjective logic. That's interesting. What is subjective logic? I don't know it.
Because it seems like Bayes is thinking through, okay, now I have more evidence about the same thing, so it's going to change my assessment of the probability.
Well, that's interesting. P of A given BC is P of B given AC. P of AC over P of, oh, that's not that useful. In that it's not symmetric. But this shows the complexity of working with independent things. Oh no, P of A given B. Is it A given BC or A given B and C? Oh, where's the parenthesis there? No, I think the comma has precedence on the given. P given AC, P of AC, yeah, that's right. And the comma here is like an and. P of B given AC, P of AC, PC. Yes, that's right. P of AC. Oh, and they simplify the P of C, cute. But. I hate
so maybe
that.
I should create an Excel spreadsheet, but I'm just thinking of, I thought I understood intuitively what this is doing, and I do, but I guess I don't know. I don't have an intuition about if I have like 5 different numbers at different levels, and I try to do Bayes' theorem on it. You know.
Okay.
I had 1 and a 0. Does Bayes come out at 0.5?
I see what's happening. If the events are independent, right?
Mm-hmm.
1 second. I'm getting P of A given E equals P of A enter B given P of B. If they're independent, P of A given B equals P of A by definition, right? That's what independence means. Now, if in the 3-case problem, if we have A and B and C independent, P of B given C simplifies to P of B. P of A given C, now we don't know that A is independent of C. P of B given AC, we don't know that it's independent either. The only simplification, I was hoping for more simplifications, but basically P of B given C becomes P of B. P of A given C is a bloody nightmare. But I can multiply by P of B, P of C. P of C given A, B. No, B and C being independent doesn't help me all that much. Still, I have P of A given C, but I don't have P of B given AC. That's what I lack. I'm supposing I have P of A given C and P of A given B. P of A and C. P of B given A and C, that's useless. Arg! Okay, oh well. No, I can't do that. And if they're independent, P of AB is P of A, P of B. Huh. Does that helpful? P of B given a C. Yeah, but I don't have independence there. No, I can't use that to get a formula. I need to find a way to have a formula for what's the probability of something given a lot of independent events, making it
Well,
more likely.
Is it inappropriate to just do no, I'm forgetting the term, the computer science term, where you're just kind of for eaching over them and reapplying Bayes' formula with the new variable on the results of the last?
Yeah, I don't know that I know how to do that. That's what I'm trying to do up to a point, but I'm not sure. Like basically, this is the root of the induction, and I'm not able to get the first step of the induction. I don't have a good induction step yet. I'll think about it.
Yeah, so is it fair to take the first event and and use that score?
Oh, I'm getting a phone. This is.
We got 5 minutes,
second.
so we can go ahead and end if you want.
Allô? Comment vas-tu? Oui, laisse-moi 2 secondes, je termine un appel. Je te rappelle dans 5 minutes. OK, d'accord. Okay, so she'll call back in 5 minutes. Yeah, let's close.
So do a reduce on it and just pass it back through using the first event as the first one. I just don't know what implications that has. Does that overweight the first one that you put in compared to all the others? Because I always feel like the prior is the important part in Bayes, and I don't have a prior. Well, or my prior is 100% true all the time.
Right, that's what you're saying. What I'm thinking is, yeah.
But still, and I guess it'd be interesting to see intuitively what's the difference between, yeah, if we had a whole bunch of pros and cons and a tree, and then we had these different formulas to see which would more closely match our intuition. But the actual, what the claim's about, I think is important, because we would have different intuitions based on, is it studies? Is it people? Are you just randomly asking people on the street? You know, different things, we would have different intuitions about.
Totally.
Anyway,
Yes. The liquid democracy answer is. Hmm.
well, this is fun.
Yeah, but I'm feeling a bit unconclusive. But I'm glad we wrote this down at least.
Yeah. Yeah,
Um,
I'll have to think about whether that's my formula or if there's any changes that I want to make. Actually, if you'd send that to me in some way, I could think through it a
Sure.
little deeper.
Yeah,
Compare it to
well,
my code.
the simple way is, let me,
Post it in Slack. Over there. Yeah, we can do that. Cool.
you see why I'm using max, right?
Yeah, I don't think that fits my intuition of the common case. I think it's a fairly common case, but not, or at least not in the way, and that's maybe my problem, because I kind of think about like politics, and we're gonna do this thing, pass this bill, and this bill has these good things and these bad things. Well,
You want to take more than the strongest into account. I hear you.
yeah.
See, that's really interesting, because if you're thinking of measurable criteria, yes, I would lean more towards your formula. If you're thinking about believability,
Right.
max is more.
Yeah, and that's
appropriate.
interesting. We may be coming with kind of different, and probably all of us in the group are coming with slightly different biases towards what type of debates
Yep.
are these going to be used on. That's what I'm starting to realize.
Yeah.
All right, well, sir, I'll let you go.
Yeah.
This was fun.
Thank you, and we'll I'll try to get something down with base, because it's getting to bother me. But I'm glad I wrote this much down.
You're on the hunt.
Ciao, ciao.
Bye.
Bye.